All right, so today we're diving deep into the world of antennas, specifically a double ridge horn antenna. You sent us some documentation on the AH220 model, and honestly, it's way more interesting than it might sound at first.
Oh, yeah.
Trust me, we're about to uncover some surprises about this piece of tech.
I'm excited to break it down with you. Antennas, they're kind of my thing.
Mhm.
And the AH220 has got some unique aspects I think you'll find fascinating.
Well, just looking at the specs here, the first thing that hits me is the sheer size of this thing. It's almost a meter wide. It even needs its own tripod to stand up. What's the deal with that? Are all antennas this massive?
That's a great observation. The AH220's size is directly related to the frequencies it operates on. The 200 megahertz to 2 gigahertz range, that's on the lower end of the spectrum.
Hmm.
And those longer wavelengths actually need a physically larger antenna to be transmitted effectively.
So it's kind of like how a bigger speaker can produce deeper bass notes.
Exactly. You need that larger surface area to interact with those electromagnetic waves. Now, the main reason the H220 is so important is because it's the gold standard for testing something called radiated emissions, which is basically unwanted electromagnetic energy that electronics can give off. And this is where things get really interesting, especially when we're talking about military applications.
Yeah, the documentation mentions that this antenna is the antenna for testing against a very specific military standard. MILO STD 461, specifically RE 102. What's the significance of that?
Well, MIL-STD-461 is all about making absolutely sure that any electronic equipment used in the military meets incredibly strict standards for electromagnetic emissions. Imagine a fighter jet trying to jam enemy radar signals. If its own communication systems aren't properly shielded, those jamming signals could actually interfere with its own operation, and that could have disastrous consequences, right?
Yeah, of course.
The AH220 helps ensure that doesn't happen by rigorously testing every piece of equipment to make sure its emissions are within acceptable limits.
Wow, so this is seriously mission critical stuff. Okay, so we've got this massive antenna, and I'm looking at the materials here. It says it's made of high grade aluminum with a corrosion resistant conductive coating. I have to admit, I was expecting them a little more high tech, like maybe some top secret alloy or something.
I know what you mean, but there's a reason for this seemingly simple choice.
Mm.
Remember, this thing is huge. Aluminum strikes the perfect balance between strength and weight, which is crucial for an antenna that needs to be transported and set up in all sorts of challenging environments. And that corrosion-resistant coating, well, that ensures it can handle the humidity of a jungle or the salty air near the ocean.
Makes sense. So it's rugged but lightweight. Perfect for the field. Now, the documentation also mentions something called radiated immunity tests. What does that mean? Is that the opposite of what we were just talking about?
You're exactly right. Think of it like this. With radiated emissions, we're testing to make sure a piece of equipment isn't giving off too much electromagnetic energy. With radiated immunity, we're testing to see if it can withstand interference from external sources. It's like making sure your electronics can handle the electromagnetic storms of the real world.
Interesting. So how does the AH220 play a role in that?
Well, instead of just receiving signals, the H220 can actually be used to generate precisely controlled electromagnetic fields. Think of it like a simulator for electromagnetic interference.
So they basically blast the equipment with electromagnetic energy to see if it can handle it. I'm looking at this typical field strength graph here. It mentions 800 watts of input power. Isn't that incredibly powerful? Like enough to power a small village?
800 watts is definitely a lot of power, but it's all relative. In the world of antennas, it's what you need to generate those strong electromagnetic fields for testing purposes. And the actual field strength you get depends on a few factors, like the distance from the antenna, and something called its isotropic gain, which basically measures how effectively it focuses that energy.
Okay, so we're getting into some of the more technical stuff now. I see these detailed specifications about VSWR and return loss, but honestly, I'm a little lost. Can you break those down in a way that's easy to understand?
Don't worry too much about those specific terms. What those graphs are basically showing is how efficiently the antenna is transmitting power. You want to make sure very little energy is being reflected back towards the source, which would mean it's not working efficiently. Think of it like throwing a ball. You want it to go where you aim it, not bounce back and hit you in the face.
Okay, so as long as the lines on those graphs look good, we know the antenna is doing its job. That makes sense. But what really stands out to me is that each AH220 comes individually calibrated, and they even provide the data with it. Why is that so important?
Calibration is absolutely critical for ensuring accurate and reliable testing. Imagine using a ruler that's slightly off. All your measurements would be wrong. In the world of antennas and electromagnetic testing, accuracy is paramount. especially when we're talking about military and aerospace applications, where even tiny errors can have big consequences.
So it's like making sure every AH-220 is speaking the same language, so to speak.
Exactly. That ensures consistency and reliability,
Yeah.
no matter where the antenna is being used.
Now, last thing I want to touch on before we move on is the accessories. I'm looking at the list here. A tripod, a preamplifier, a spectrum analyzer. Are all of these essential for using the AH-220?
Not necessarily essential for basic operation, but they're like specialized tools that can enhance the antenna's capabilities, depending on the specific testing needs. For example, the preamplifier can boost weak signals, which is helpful when you're dealing with very low emission levels,
Hmm.
or testing at a greater distance. It's all about getting the most accurate and detailed picture of the electromagnetic environment.
Okay, so it's like having a whole toolkit to fine-tune the testing process. So far, we've learned that the AH-220 is this massive, powerful,
Right.
and incredibly precise antenna, primarily used for testing radiated emissions in demanding environments. And it seems like it's a crucial part of ensuring the reliability and safety of critical equipment, especially in the military.
That's a great summary. It may seem like just a big piece of metal, but the AH-220 plays a vital role in a world increasingly reliant on complex electronics.
Okay, so we've established that the AH-220 is a pretty serious piece of equipment, especially when
Right.
it comes to those radiated immunity tests you were talking about. I'm looking at this graph here labeled typical field strength with 800 W input power. And it looks pretty intense. What's the story here?
Well, that graph is essentially a roadmap for understanding how powerful the AH-220 can be. When it's generating those electromagnetic fields, it shows you the field strength it can produce at different frequencies when you crank it up to its maximum power of 800 watts.
So if I'm understanding this correctly, at certain frequencies, it can create a field strength of over 150 volts per meter. That's a lot of energy, right?
It is. And keep in mind, that measurement is taken just 1 meter away from the antenna. The further away you get, the weaker the field strength becomes. That's why it's so important to carefully consider the distance when you're setting up these tests.
Right, so the testing distance plays a big role in how much that equipment is getting blasted with electromagnetic energy. I'm also seeing this formula below the graph. Field strength, VM, input, WO, 30 numeric gain test distance, woo-hem. What's going on with that?
That formula is like a cheat sheet for calculating the expected field strength in different testing scenarios.
Hmm.
Let's say you need to hit a specific field strength at a certain distance. You can plug those values into the formula, along with the antenna's isotropic gain, which you can find on a separate graph. And it'll tell you exactly how much power you need to feed into the antenna to achieve that.
Ah, so isotropic gain is like a measure of how focused the antenna's beam is.
You got it. Imagine a flashlight. A focused beam will be much brighter at a distance than a wide, unfocused beam, even if they're both using the same bulb. Same principle here.
That's a great way to visualize it. So by adjusting the power and the distance, you can create all sorts of different electromagnetic environments for testing.
Exactly. It's like having a dial that lets you control the intensity of the electromagnetic storm you're creating. That level of precision is crucial for ensuring reliable and repeatable results.
Now, I have to be honest, looking at all these graphs and formulas makes me feel like I need an engineering degree to understand this stuff. Do I really need to grasp all the technical details to appreciate what makes the AH-220 so special?
Not at all. While the engineers and technicians who work with the AH-220 need to understand the nitty-gritty, for most people, it's enough to appreciate the bigger picture. It's like admiring a beautiful painting. You don't need to know the chemical composition of each pigment to enjoy the artwork, right?
That's reassuring, but I am curious about one thing. The documentation mentions SAE ARP958 and NIST traceability when talking about calibration. Can you shed some light on why those are important?
Those are all about ensuring that the AH-220 is as accurate as possible. SAE ARP958 is a set of standards that outlines very specific procedures for calibrating antennas like this one. It's like a recipe that everyone follows to make sure their measurements are consistent.
So it's like making sure everyone's using the same measuring stick, so to speak.
That's a great analogy. Now, NIST traceability takes things a step further. NIST stands for the National Institute of Standards and Technology, and it's basically the ultimate authority when it comes to measurement accuracy in the United States.
So it's like having a seal of approval from the measurement gods. No wonder this antenna is so trusted. For those high-stakes military and aerospace applications, where even a tiny error could be a big problem.
Exactly. When you're dealing with sensitive equipment and critical systems, you need to be absolutely certain that your measurements are accurate. There's no room for guesswork.
Okay, I'm really starting to see the science and precision behind all of this. It's not just about pointing an antenna and hoping for the best.
You got it. It's about meticulous engineering, rigorous testing, and ensuring the highest levels of accuracy.
Now, I want to circle back to those accessories we were talking about earlier, specifically the PAM-103 preamplifier. What's its role in all of this?
That preamplifier is a real workhorse when it comes to boosting weak signals. It's like giving them a little extra volume before they reach the spectrum analyzer.
So if you're dealing with equipment that's only emitting very low levels of energy, the preamplifier can help you get a clearer picture of what's going on.
Precisely. It's especially useful when you're testing at greater distances, where the signal naturally weakens. It's all about increasing the sensitivity of your measurements.
Interesting. And speaking of getting a clear picture, the documentation also mentions these SPA 900TG series spectrum analyzers. What exactly do those do?
Those spectrum analyzers
Yeah.
are like the detectives of the electromagnetic world. They allow you to see all the different frequencies that are present, how strong they are, and how they're changing over time.
So the AH220 captures the signals, the preamplifier boosts them if needed, and then the spectrum analyzer helps you make sense of it all.
That's a great way to put it. They work together to paint a complete picture of the electromagnetic environment.
I'm noticing some other antennas listed in the accessories section, like an active loop antenna, an active monopole antenna, and some biconical antennas. Are all of these used for similar types of testing as the AH220?
While they all fall under the umbrella of electromagnetic testing, they each have their own strengths and weaknesses, making them suitable for different situations.
So it's like having a toolbox full of different wrenches, the right tool for the right job. What makes them so different from each other?
That's a great analogy. Think of it this way. The active loop antenna is particularly good at detecting magnetic fields, while the active monopole antenna is more sensitive to electric fields. And those biconical antennas you mentioned, they're like the multi-tools of the antenna world because they can handle a really wide range of frequencies.
It's fascinating how each type of antenna is designed for a specific purpose. It really highlights the complexity of the electromagnetic world.
Absolutely. And that complexity is only going to increase as technology continues to evolve.
Thinking back to how important the AH-220 is for testing against that military standard MIL STD-461, it makes me wonder about the future of these kinds of standards. Are they constantly being updated as technology advances?
That's a great question, and you're right on the mark. Standards like MIL STD-461 are living documents. They can't just stay static. They have to evolve along with the technology they're meant to govern.
So with all the advancements we're seeing in wireless communication these days, the Internet of Things, 5G, and everything in between, how do you think those testing standards will adapt? Will we see even more specialized antennas like the AH-220 emerging?
It's hard to say for sure what the future holds, but one thing is certain. The need for reliable and robust electromagnetic testing is only going to grow. As we pack more and more wireless capability into our devices, the potential for interference increases exponentially. That means we'll need even more sophisticated tools and techniques to make sure everything works harmoniously.
So in a way, antennas like the AH-220 are the unsung heroes of our increasingly interconnected world, ensuring that our electronics don't descend into a chaotic mess of interference.
I love that way of putting it. They're essential for maintaining order in the invisible world of electromagnetic energy.
Well, we've covered a lot of ground today, haven't we? We started with what seemed like a simple double ridge horn antenna, and we've ended up exploring a whole universe of electromagnetic testing and its crucial role in modern technology. Is there anything else you want to leave our listener with before we wrap up?
I just encourage everyone to take a moment to appreciate the unseen forces that surround us. Every time you use your phone, connect to Wi-Fi, or even turn on a light switch, there's a fascinating world of electromagnetic energy at work. And behind the scenes, there are talented engineers and scientists, armed with incredible tools like the AH-220, working tirelessly to ensure that it all runs smoothly.
Well said. On that note, we'll wrap up this deep dive into the world of the AH-220. Thanks for joining us. And remember to keep exploring the hidden wonders of the world around you.